My name is Sankalp and today I'm going to show you the result for my lab 8. Basically this is about fractals in L systems. What fractals in L systems are basically we cannot represent a lot of natural objects in this world using Euclidean geometry because that is highly it's not that simple, and the way we can do that is by following certain rules and repeatedly using them to form particular diagrams. We can check the in examples here. L systems, also known as linear systems, helps us for form objects like these, as you can see here. These almost look like natural structures, but we achieve them using the algorithms used by L system. What this basically is we're basically we have some particular rules, we have an axiom, and we're basically constantly substituting them based on the rules, and this gives us the final output. Once we get the final output, based on this output we can map our graph. This is an axiom. Based after each recursion we can create a new structure. Here are certain examples like fractal, which is binary tree, Cantor set, coach curve, etc. Right now I have done coach curve. As you can see here, I'm going to demonstrate this to you first. I've done the algorithm. I'll just show you the output first. So in draw here I put f0. Let me just put this as 0. So basically this is the basic unit f. I've not done any iterations on it, and this is the line. So after doing one iteration, this is how it changes to, because it's applying this particular rule where it replaces f with f plus f minus f minus f plus f. It's the same thing used here. It's basically a coach curve, and plus and minus indicate the way it's turning. So basically it's 90 degrees is the angle, and plus indicates turning left and minus indicates turning right, or it could be vice versa. Now you can see it's the same one that we have over here because this is the rule. Now after doing two iterations, this is the structure formed. This is the same structure we see here. It's just the orientation is different. This is horizontal and that is vertical. Similarly, if I change to 3 iterations and run the code, it forms it. Let me just zoom out. As we can see, this is a bit to the, it's been covered. Let me just change the position. Let me change this to 1000, and as you can see, this is the output, and this is the same output we have here. So this is how basically fractals work, and now I'll tell you how the algorithm roughly works. So this is all usual. Basically this I use this replace all in order to do the substitution of our string based on the production rules. This point, what I'm basically doing is to plot this thing. Given a starting point, let's say this is the starting point, I calculate this point using trigonometry and plot the next point. So when I get the 2 points, I use the line function to draw the line. Then this frac function is what replaces f from the string with this particular thing, which is basically what our rule is supposed to do. And this iteration runs frac function multiple times and make sure that we get the new output as the input for the next step. This is how we iterate. That's what iter stands for. And this is the function where I define the constants and what we're supposed to do based on the output given by the iter function. That's it for today, and thank you. Fractals are a way of making a natural plotting natural objects on a graph. This is hard to do in Euclidean geometry, and using this would make plotting things on a graph much, plotting things easier.